Hello and welcome back to this series on SURDS. So in the last few videos we've learned how to add and subtract and divide and multiply as well as simplify the SURDS. So now we're going to be looking at binomial products that have SURDS in them. Now you might be thinking to yourself, what the heck is a binomial product? So pretty much a binomial product is sort of a number that is in this form. So we can have either this one, so that's our form number 1, so that we've got one number out the front and then this sort of other mix of numbers there, or we can have form number 2 in which we have two lots of these numbers in brackets. So if we see something like this or like this, then it is going to be a binomial product. So a binomial product with SURDS is where one of these or more than one of these is in a SURD form. So it can be any number under there, but if any one of these is a SURD, then we got a binomial product in SURD form. So binomial products don't have to involve SURDs, but each of these numbers here, they just represent a different number. Okay, so it could be a SURD, it might not be a SURD. So what I'm going to need you to remember from the last tutorials is that when things are sandwiched together like this, so we've just got our A and then it starts our bracket, or we've got this but there's nothing in between, remember that what this is short for is it is short for a times. So we've got a times here and a times there. Now, as you'll hopefully be noticing, now what we can see is that we have both times as well as plus. So we've learned how to do our times and our dividing of SURDs in our previous lesson, and we've learned how to do our plussing and minusing of SURDs in previous lessons. So now we're going to be trying to put all of this together because we have both times and divide as well as plus and minus. Now before we get into a few examples, we're going to need to first go through some special types of binomials. So our special type number 1 is going to be in the form like this. So let's say we have two numbers. Either of these could be a SURD or they could not be, but then we have a to the power of 2. Remember, to be a binomial product, it has to be in one of these two forms. So that's our form 1 and this is our form 2. But what we're seeing here is this doesn't exactly look like either of them. So how is it a binomial? So the reason why this is a binomial is because, as we should know from our previous lessons, this to the power of 2 I can see up there. What that basically means is that's saying that this is times by itself. So what we're actually seeing here is we're seeing A plus B, A plus B together because we're timesing it by itself. That's what that to the power of 2 or squared means. So now that we can see that it's actually in a short form for this, that looks a whole lot more similar to our number 2 form, which is A plus B and then C plus D, except instead of C plus D, we just have the same A plus B over again. So it is a binomial product. So remember, what expand means is we want to put it into its long form. So right now it's still in a shortened form, even though we've made it a little bit longer, but we want to take it apart into all of its little bits and pieces. So how do we go about doing that? What we would normally do if this was just a single number, let's just say if it was, I don't know, Z, we'd times this Z by everything in the brackets there, right? But here we have two numbers that are going to get times together. So how do we go about doing that? So what we're going to do in this case is we want to times this by both of these, treating it as one number, but we can't exactly do that. We're going to have to make sure that we do it bit by bit. So we're first going to times the first number of these by each of them, and then after we're finished doing that, we're going to do it with this second lot. Okay, so if we end up doing that now, just to have a look, what we end up getting is we get A times A, which is going to be what? A squared, because we're timesing it by itself. And then we go on to our next one over here, A times B plus AB. Okay, we're going to go on to our next one over here, B times A. Now that's the same thing, that's plus AB again, isn't it? Now BA and AB, same thing. And our last one over here, which is B times B, which is going to be B squared. Now hopefully you should be able to see that these two in the middle here are like terms. So now we have two lots of AB. So what we can do is we can write that as two lots of AB plus the extra B squared on the end. So we've taken all our like terms, put them together, and the expansion of this special type number 1 is this down here. Now I want you to notice here that there is a plus out in front there. Okay, so our second type number 2 is very similar to our special type number 1, and what it's going to be is a minus b squared. So it's the same thing, except it's a little bit trickier because we have to take into account this negative there. So it's going to be the same thing, it's the same expansion for a minus b, a minus b. Now remember there's an invisible times there, and what we should also remember is there is an invisible minus 1 here. So we're going through the same process again. We want to times everything in here by both of these. In order to do that, we've got to do it bit by bit. So let's start with this a and a first. We're going to get what? A squared again. Now they're both plus a's. So that just means it's going to be a plus a squared, because a positive and a positive is a positive. So let's go with our second over here. Okay, now remember we got our minus 1 out in front. So we've got a plus 1a and a minus 1b. So you've got to take into account the numbers out the front. So we're timesing the 1 and the minus 1. What does that equal? Minus 1. And then we're going to times the a and the b, which gives us a b. Okay, so now we've done all of our a bit. That's done. So let's go into this minus b. Remember we've got our minus 1 out in front of this b. So minus 1b times our plus 1a. So let's times the numbers. Minus 1 and plus 1 is again minus 1. Now I know we could write this as ba when we times the numbers, but I'm just going to write ab for simplicity's sake. Okay, so again we got minus 1ab. And now for this last one, this is where it's going to have to take into account the negative. So we've got a negative 1b and a negative 1b. What's minus 1 times minus 1? Okay, it's a tricky one. 2 minuses makes a positive. So it's going to be plus 1. And then b times b is a b squared. So can we simplify this any further? Yes. So we're not going to write our plus 1s out in front this time because we don't need to. So let's start with our a squared. That's fully simplified. And we can put our plus b squared at the end. But what goes in the middle here? So we've got minus 1. Okay, so here's 0 on the number line. We've got minus 1 and then minus another one. So when we're minusing a number, we're going towards negative infinity on the number line, aren't we? So we're going to take one step closer to negative infinity, which is giving us minus 2. Because remember, we go more negative the further away from 0 we get. So we've got minus 2 lots of AB. So that's what this looks like. Okay, so remember here, there's a minus. So when there's a minus in the middle of this a minus b squared, we know that there's going to be a minus out there. Now you don't need to remember that, but you're going to want to pay attention when you need to expand something similar. So this isn't always going to be a or b. It's going to be something different, but you're still going to need to take account of these and be careful of these negatives. Okay, so our third special type is a little bit different to those two that we've already done. And what it's going to be is it's going to be a plus b and then a minus b. So again, we've got the same number being represented, okay, but we've got a mix now. We've got a plus and a minus. Okay, now this is a very special case, as you will see, because what we're going to call this one later is going to be the difference of two squares, and you will see why. Let's get started with our first one. So we've got, remember, a plus 1 out the front here, a plus 1 out the front here. Okay, times the numbers. What do we get? 1, and then a times a squared. Okay, moving on to our next one. Now this one we have a minus 1 in front. Okay, so minus 1 times 1 gives us minus 1, and then a times b gives us a b. Okay, so going on to our next one. Now here we got a plus 1 in front, a plus 1. So times the numbers, what do we get? Plus 1. And again, we're going to go a, b. And now our last one, which is going to be plus b and minus b. Okay, so do the numbers. What's a plus and a minus makes a minus, and b times b is b squared. So why is it that this expansion that we've just figured out is called the difference of two squares? So let's find out. So we've got our plus 1 a squared. Okay, so that, is there any other a squareds? No, so that's going to stay the same. A squared. Okay, now here we go. We've got a minus 1ab and a plus 1ab. So these are both ab's, so we can plus and minus them. So remember on the number line, if we're starting with minus 1, so here's 0, here's minus 1. If we're going to plus 1, which way are we going? Going a different way this time. We're going one step towards infinity. Okay, so we're going one step this way. Where do we end up? 0. So 0 lots of AB, and then there's no other b squared, so we keep that out how it is, minus b squared. So when there's 0 of something, what does that mean? It means there's none of them, so we don't need to write that bit down. So what are we left with? Now remember, this plus 1 is attached with that, so we can cross everything out, even the plus, and then we get a squared minus b squared. So it looks very simple, and the reason why this is called the difference of two squares is because difference means minus, okay, the difference of two squares. So notice here that these are two squares. So the same works in reverse. If we see something that is a difference of two squares, we know that we can rewrite it in its form like this: a plus b, a minus b. So just to show you what I mean, showing that this can go the other way around, is if we notice that we have a square here and a square here that is being differenced, then we can rewrite it in its form. So what is this squared? So we're asking what number squared will give us that. Okay, so we're going to split it into the two parts. We've got the 9 and we've got the x. Now we know 9's a square number, and 3 squared will give us 9. X will give us x squared. So if we were to times this whole thing squared, that would mean that we'd have to go like this, right? 3 squared times x squared, which would give us 9x squared. So that is a square up there. Okay, so we've got our first one. So our a from before is our 3x in this case. So we've got our minus, that's good. What about this side? So we have 16. What's going to get us 16? So 4 squared will give us 16, right? And y squared will give us y squared up there. So this is going to be our b from before. So because we know it's a difference of two squares, and this is our a and this is our b, we can rewrite it like this. So we can plus 1 and we can minus 1. Okay, and that is going to be exactly the same as this up here. Now the reason why we want to do that is sometimes it's going to be easier to work with this, especially when we're working with parabolas later on.